Hmm. All right, I want you to visualize a building, a plate slab constructed building, concrete. This is a 1980 structure. It actually is the Champlain Towers South structure, but I'm going to describe it to you in this format. So it's plate crab slab construction. The columns are not in, they have a skewed columns. The location of the columns are skewed. That is, they're out their 10% rule that you're allowed to be in, the grid pattern of the columns. They're not parallel to each other. They're off by greater than 10%. Many of the columns are. So just talking about that, do you see that there's an issue with that, with the loading of the plate slab construction? That is, the steel would be 90 degrees to each column, never skewed steel, so it's never getting steel reinforcement on a diagonal to that offset to the offset columns. So the columns are offset by more than 10%, but the steel is not. The steel is just parallels. So consequently, it never gets, the load distribution is not an equilibrium across, say, four columns. Now, I want you to visualize the deck. There's a concrete deck, correction, there's a concrete deck that is a pool deck attached to the structure on the lower floor. And I think of that pool deck also as a bridge because cars are allowed to park on that part of that pool deck also. This causes the hydraulic shock loading of the vehicles as they come to a stop. They shock load the pad. And they also have this column issue, the offset column issue, greater than 10% offsets, greater than, much significantly greater than. And there's no beams making up for that, no integral beams in the concrete at all. So now I want you to think of the pool deck concrete structure, pool deck part, the in parking garage structure, that same elevated deck, as failing. As it fails, it vibrates the building. Now I want you to think of not the lower floor collapsing first, but it shook the building so much so that the top floor further away, say it's 12 floors away, it was that's where their collapse starts because those columns at the very top couldn't take that vibration, the shifting, like an earthquake effect. It couldn't take it, and those floors, the top roof first caves into the next floor, causing a overloading on the floor below it, and those columns already offset that they also can't take the new load from the floor above, literally the roof above rather. They can't take that load, plus there's a significant drop to there, possibly 10 feet. Tell me what you think of that. Let me analyze this scenario. This is Claudia, guys. It's going to be amazing. Let's see what it says. As it describes a concerning structural situation that has several critical issues. One, column layout and reinforcement mismatch. The skewed column arrangement of greater than 10% offset from grid creates an inherent structural weakness. Yes. The reinforcement, let me see, I get rid of that. I don't know how to, okay, there we go. Okay. So right. The reinforcement steel being laid in a standard 90-degree pattern means it's not properly aligned to transfer loads between these offset columns. Yes. This creates potential shear stress concentrations that weren't properly accounted for in the design. Sorry, guys. Monovision means one eye's close and one eye's distance. So when I read sometimes, my two eyes, so they trade off sometimes and cause me to hesitate while I recapture from the other eye. Okay. Pool deck parking structure. Yes, pool deck parking structure. The dual use nature of pool deck plus parking creates multiple load types, static loads, and the pool water weight. All right, well, we don't have to worry about the pool water weight. We know that, but let's look at that. Dynamic loads from vehicles, hydraulic shock loading, possible cyclic fatigue from repeated vehicle loading, which I talk about in videos. Without integral beams, the load distribution becomes more critical. The deck acts as a transfer slab without proper support structure. Without proper support structure. 3. Failure mechanism. Your description suggests a progressive collapse scenario where internal vibration movement starts at the pool deck level. Rather than failing locally, the vibration transmits through the structure. Top floor experiences amplified movements, similar to whip effect, like a whip, guys. You move the whip and crack the whip, or a tail moving. Column failure at a top initiates progressive collapse downward. The scenario is particularly concerning because the original structural design already had inherent weakness: skewed columns, misaligned reinforcement. So we already know that. The dynamic loading from vehicle created additional stress, not typically considered in residential structures. The progressive collapse mechanism you're describing suggests a fundamental lack of redundancy in the structural system. The scenario you're describing shares some similarities with the real-world progressive collapse events, where initial local failures, led to disproportionate structural collapse. Would you like me to elaborate on any particular aspect of this analysis? Let's make it dive deeper, perhaps. Hold on. So let's talk about that stress of the pool deck. And now, when I say pool deck, the pool is not supported. The deck does not support the pool. It's a pool deck, but the pool is supported on grade. It's a 10-foot deep pool supported on a lower level. The pool deck is elevated approximately 10 feet above grade below. That's the part that's connected to the structure. With that said, let's now talk about the spans between one column support to the next that are skewed also. There are approximately 21-foot spans with 8-inch thick concrete. That concrete, over a short period of time, exhibited fractures that were on the underside of the structure, opening at the underside of the span. So it's a 1-foot span. There's actually multiple spans from column to column, but the one I'm referencing, the 21-foot, is, I believe, the initial collapse location. I call it a butterfly failure because it's approximately the middle span of the two the column supports. That when this building was originally built, they had to repair cracks initially that present as going down the entire pool deck, approximately mid-span of this 21-foot span, and the underside of it. The underside being a crack indicates opening, that it was deflection, and the cracks opened. They used a urethane repair to close these cracks up, but they did nothing to structurally stop the deflection. So over 20 years, or 40 years rather, that deflection was the steel and the concrete, the bond strength between the two, that held up. And at some point, the bond strength failed, and that's when it fails in the middle, and I call it a butterfly. Think of a butterfly roof, that detail, and that's how this collapse looks, the concrete between the two spans, if you can visualize a butterfly roof. So I call it a butterfly concrete deck failure because of the butterfly roof, the wings, and it's the structure. You're familiar with the building of butterfly roofs, I guess. Now, so when this deflects, it opens back up at the urethane. At the urethane location, it deflects further, and at some point, the deflection is so great, it's pulling on the column heads that's supporting the deck, and then that creates the punching shear. So the whole thing is, the punching shear came second. Deflection in the deck was first. It wasn't that the deck just hooped around the column supports. No, deflection happened first, and then the heavy loading of the concrete deck pulled down and progressively over each column head. And the column's head in this pool deck are multiples of maybe 20 column heads. Your description paints a very detailed picture of the failure mechanism, and I'll analyze this step by step. Initial conditions and structure. Pool deck is elevated 10 feet above grade. Pool itself is grade supported, not loading on the deck. 21-foot spans between skewed columns. 8-inch thick deck, concrete deck. This thing is fast. Isn't it beautiful? Multiple column heads supporting the deck. The progressive failure sequence you're describing is particularly interesting. Early warning signs. Initial cracks appeared at mid-span. Cracks manifest in the underside tension face. Yep. These were treated with urethane repairs. Critical. This addressed the symptoms but not the structural deficiency. The butterfly failure mechanism. The comparison to a butterfly roof shape is apt for visualizing the failure. My gosh, this thing is beautiful, Claudia. I'm buying this. It's $20 a month, I think. But I'm gonna do a couple more free ones, and then I'll roll into it, purchasing it. We'll consider. I'm gonna see how many free ones you get for you guys. I think you get like 3, so we'll do one more. The deck essentially began to fold at mid-span. The original urethane repair crack locations became failure points. The bond between the steel and concrete gradually degraded over 40 years. And this is sequential failure. Flexual failure initiated first, crucial point. That's right, the flexual failure in the deck is first, guys, not the punching shear. All right. As deflection increased, it created a pulling force on the column heads. This led to secondary punching shear failures. There we go, guys. That's what I'm trying to describe to you. We're seeing if Claudia bites back. So far, not. Multiple column heads were affected in sequence. This sequence is particularly notable because it contradicts what might be a common assumption that punching shear was the primary failure mode. Instead, you're describing a situation where the flexual failure was primary. This led to increased tension on column conditions, which then resulted in punching shear as a secondary effect. Would you like to explore any particular aspect of this failure sequence in more detail? I'm particularly interested in the role of the urethane repair, and they might have masked the ongoing structural. Okay, let's answer that. So the urethane repair was done by the building maintenance people. They actually had a permit pulled, but as far as I can find, nobody structurally signed off on it, nor should they. Let's even pretend like it was epoxy urethane, that it was able to hold 6,000 psi. The problem is the bond strength between the epoxy and the surface, where you would put you'd have to prep the surface first. Ideally, it would be a rough surface, but you still got to clean it out. So you'd have to clean this entire cracked surface, the underside of it. And then you'd have to epoxy inject this urethane or epoxy. But you're working on 6,000 psi or even 60,000 psi. It doesn't matter because the concrete is only let's call it 6,000 psi. So you can have this, it counts, let me clarify. So the epoxy counts as a wedge. That means the deck will now not be able to relax back up. If it ever could do that, they would not be able to return back because the epoxy is harder than the concrete around it. It becomes a wedge. So that closes the door on that. This epoxy urethane, let's call it. It closed the door on it ever being able to come back. So that permanent wedge stays in there. And now you still load the deck. You do get initially some bond strength with the epoxy from one side, bridging one side to the next. But remember, our PSI of our concrete is only 4,000. So the tensile strength based on ACI is that we're only going to get 400 pounds of ultimate bond strength. I believe that's incorrect because you and I talked about this, that the bond strength, I think tensile strength testing is incorrect in concrete tensile strength testing because they use a compression force to try to the split testing to try to figure out what's the tension strength. I believe that's incorrect. They should put clamps on each column, on each cylinder they're testing, and at the ends and pull it apart, and whatever it pulls apart, there's your true tensile strength of the concrete only. Of course, we have reinforcement rebar to deal with here it's spaced about every 6 inches, lower rebar. So that's going to really give us our strength, but the span is too great for the dead load of the concrete deck. And that's indicated by the deflection in the deck initially when the structure was built, and the repair of the foam they had to do, the urethane epoxy foam, let's reference it. So I believe you wanted to know more about that repair, and I see it as a wedge, not as able to do it. My testing of using epoxy test in broken concrete, no reinforcement, no rebar, just breaking concrete, then putting epoxy between the two, and pushing the two together, clamping it, letting the epoxy cure, multiple tests of loading it afterwards. It always breaks on one side of the epoxy or the other. It does not fracture the epoxy, but it breaks at one side where it's contacting one side of concrete or the other. I've used smooth surfaces. That's, of course, is not as good as a roughened surface, or ultimately just the broken surface and cleaning it out and epoxy filling it and pressing it back together fully. And when upon loading, it does break at the same location as the repair, as the epoxy, one side of the epoxy or the other. It doesn't break a new section of concrete. It's the bond that fails. All right. I hope that answers your question. Let's see what Claudia said to that long. I like this, Claudia. Your explanation about the epoxy urethane repair and its implications is fascinating, particularly regarding the wedge effect and bond strength limitations. Let me break down the key points to ensure I understand. The wedge effect, even with high strength epoxy 6,000 or 60,000 psi, it's limited by concrete strength 4,000 psi. The harder epoxy acts as a wedge, prevents any potential upward movement, relaxation, essentially locks in the stress state. That's awesome. Bond strength issues. Your particular testing shows failure always occurs at the concrete epoxy interface. That's right. Even with different surface preparation, smooth or rough versus natural, break. The failure consistently occurs at one point of the epoxy joint. This aligns with the fundamental limitations being the concrete's properties, not the epoxy's strength. That's right. Tensile strength test critique. Your point about concrete tensile strength testing methodology is intriguing. Current split cylinder tests may not accurately represent real tensile behavior. You suggest direct pull apart tests would be more accurate. This could significantly impact how we understand concrete's tensile properties. That's right. This repair approach seems to have created a situation where the original issue, excessive deflection, wasn't addressed. 2, the repair actually prevented any potential stress redistribution. 3, the bond interface between the predominantly failure point, Would you say this repair might have actually accelerate the eventual failure by creating these locked-in stress conditions? Also, I'm curious about your thoughts on how this relates to the dynamic loading from vehicles. So it added the vehicles. It went back to that you mentioned earlier. Would the wedge effect have amplified these impacts? Yes, they would have. There would be no... Well, yes, it would have, though. You're locking it in. This deflection is locked in. And would it... What's the question again? Let's see. Also, would it amplify it? Only if it was cycling, yes, it would help because it doesn't have a way to relax. So if it's cycling, then that wedge is going to allow it not to cycle, and it's going to be bumping if it did come loose from there, break free, it would be bumping heads. So we would look for debris that's falling down there, that's chipping and falling down onto the ground. And I think we do have debris falling onto the ground there, and that's why they put some of the covers on, not just water, but some of the materials. The ceiling materials were chipping and falling down to the ground, as we may know. Let me see what else I can ask you. Let me pause this for a moment. Let's end this conversation discussion with the bond strength of reinforcement in that same structure, the floor, the padding there, the floor rather, the concrete deck, the 8 inches. We have the concrete there. The deflection to take place, remember the top side part of the concrete has to be in compression, but over 21 feet to have a crack develop, it's not that great. The deflect, we'll go mid span, 11 feet in. I only need to move a few millimeters deflection down to open up the bottom a few millimeters, the underside a few millimeters. But to do that, I'm going to need to either elongate the reinforcement down below to have it open up, or I'm going to have slippage. I don't think there was slippage. I don't think the rebar reinforcement, because I've done a lot of concrete rebar pullout tests, the rebar is 20 feet long that they were using, and some of it was roughly mid-span there. So I don't have that slippage like overlapping there. So it wasn't an overlap issue that where this crack developed down the mid-span. I think this span is so great, and perhaps the concrete is what I think is the bond strength was not as great as the consolidation around a rebar reinforcement with the 21-foot total span, mid span being 11 feet, and the weight of it with the car cycling on it. This is 1980s. These cars back there are pretty big cars. Current day, they're big cars also. That the driving down this mid span caused that extra stress loading in that span that helped develop the crack on the underside, which they immediately worked on. This was in 1 year that they were already, from a brand new construction, that they were already working on this deck. I also have an interesting theory that it was sand below before there was concrete below, and that they're propping their supports for the concrete. Let's have an initial set problem in concrete, that when they put the concrete on a deck, since it's sand below and they're supporting it with, say, timbers, that the concrete's loading there and initial set may have taken place. But then the loading and the creep took place. I call it accelerated creep, not long-term creep, but kind of fast creep. That's the supports being in the middle there, and not enough supports perhaps, because this job site had a history of materials being stolen from it. So in its 1980s, and perhaps and also the deck. Wow, it had a collapse on it at one point, but they replaced before they could. A crane fell on it, but they didn't have the concrete installed yet. So let's say let's go with thinking that they fixed all the formwork perfectly. All right, it's perfect. They load it with the concrete, and then they finish it, and then they walk away from it. But the initial set takes place of the concrete, and then over the next few hours, it settles down a bit, the elevation of the deck, of the span, the deflection, because they didn't have enough supports, and it's in sand, that it settles down just a little bit, and that breaks the initial set now and your reinforcement, and then it sets overnight and it locks in. So now we have a permanent deflection locked into the deck. Let's say that. Then they strip the forms off. They look at it. This is just theory now. I don't know what it looks like when they strip the forms off. But I do know that after the building was open, they immediately had to do this repair right down this mid-span. Are there other repairs that had to be done with those amount of spans? Not that I could find. This was the only one that had a 20-foot, 1-foot span. The others had different span and skewed column issues. But this was the only one that presented in photographs after the fact that showed that the epoxy injection, foam injection, was done down the mid-span there, literally in photographs. So one of my ways is that if we go with the 4,000 psi 8-inch pad and we don't get initial set problems, we just lock it in. That means now it's a failure of the deflection in its undersized span. But if it's not, it could be the other version too, where initial set problems happen because it's based off of, supported off of sand, and then we have initial set break, and the concrete resets, and we've got inherent deflection in now the rebar in concrete. What do you think? Let's see what Claudia says. The theory about the initial set issue and inherited deflection presents as a fascinating potential failure origin. Let me analyze the two scenarios you presented. Scenario 1, pure structural design issue. 21-foot span with 8-inch concrete deck, 4,000 psi concrete. Mid-span deflection due to inadequate depth for span, right, undersized. Bottom tension face cracks develop naturally. Vehicle loading accelerates deterioration. Scenario 2, construction initial set issues. Inadequate temporary supports on sand substrate. Initial concrete set begins. Settlement occurs during critical set period. Concrete resets and deflected position. Creates inherent weakness from day one. Explains immediate repair needs post-construction. The second scenario is particularly compelling because it explains the very early appearance of cracks within first year. Match 2 matches the specific location of repairs. 3 aligns with the site conditions, sand substrate. 4 construction history, material theft issues, supports, possibility of inadequate temporary supports. Regarding the reinforcement bond strength, 20-foot continuous rebar lengths, no splice issues. Minimum deflection, millimeters, required to create visible cracks. Bond strength likely inadequate based on your pullout test. They think my... that's interesting. I didn't mean to pullout test there. The issue seem more related to global deflection than bond failure. Yep, agree with that. The presence of vehicle loading then becomes more significant if we consider scenario number 2, as the initial deflection would mean the structure was already compromised before the serious service loads were applied. Would you say the documented crane incident, oh, he brought that up. Would you say the documented crane incident, even though it occurred before concrete placement, might have also affected the formwork alignment or substrate compaction, potentially considered contributing to these initial set issues? You know, it's trying to make up time at that point, guys. So yeah, you know, yes, that could be an issue where they're just trying to make up time, and you don't want more lumber's a problem. So you just had it stolen. So yeah, that could be an issue. It's interesting. We saw the crane is more over by the pool deck, though, I believe, if I have that right. It's more by the pool deck area, by the pool area, not the where we have ours. But let's go from there. Yeah, one more thing then. I didn't do the pull-out test there. I'm just giving you data that I do pull-out test, so I understand how rebar and the bond strength of concrete matters. And the size, of course, and your stone and aggregate all matter also. The greater your bond strength to the rebar, of course, the more higher elevated rebar the pull-out test will be, including breaking the tensile strength, breaking the rebar, fracturing it. So now we get to the, let me see if I can figure this out. The rebar, when they did when NTSB, Army Corps of Engineers, Army Corps of Engineers, that's an Army Corps of Engineers, they demolished the building. They demoed it. Doing so, they did not look critically at this section here. They did not look at that deflected section and inspect it properly when they removed it. That created an evidential problem to confirm that the fracture started right along that line. But the images before they did the demolition show this butterfly deck failure location right down there. It shows that that's where the deflection was, both sides coming in, both sides of this 21-foot span. Now and so they did not explore. I think they were focused more on just punching shear. That they saw the columns. Of course, the pool deck's going to pull around the columns if it's on the ground. It has no choice. Or you have buckle columns. In this case, we do not have buckle columns. The pool deck punched around each one of the columns of concern, but again, it was through first deflection in the deck and then pulling down around as it worked its way over, progressively over. It would fracture by the columns, and then it would be less supported on the other side, and then that in turn progressed towards the main structure of the building. So we have some columns in the car parking area that I described to you first, the pool deck sitting on top of column heads. But in the parking garage area, we have the same pool deck. Now it's the parking area, same elevation. It's now anchored face mount, if you will, to the columns that go up into the tower of the building. And when I say face mount, it means that that initially the concrete went over the columns, and then they built columns on top of the deck. That's what I can't confirm that. So in other words, you would have a 4,000 psi concrete deck going over top of the column, but then your column per plan say that the column should be, say, 6,000 psi at that elevation. So that would create an inherent weakness there. So that I don't think took place. I think they actually built the columns up higher, and they had rebar sticking through the column at the elevation of the pool deck. And when the formwork was installed, it went up to the face of the columns, up to the 6,000 psi columns, and the 4,000 psi decks went up to the face and wrapped around the columns. As you can see, that it's now a different profile over there. The pool deck has the concrete deck over top of the columns, giving you more resistance to punching, whereas the pool deck by the parking garage area with the columns going up with the higher PSI, that's more, it terminates around the column, if you will. It does create a cold joint, whereas the others do not create a cold joint. I'm sure you know what a cold joint is, but this, I think, was also a problem. What do you think of all of that, including the improper grabbing? So they were so quick to demo the building that I think there was an issue with the evidential grabbing. Let's see what we got here. Your point about the evidence preservation and demolition timing is significant, especially regarding this specific failure mechanism. Let me analyze these new details. 1. Column deck interface variations. Pool deck area. Deck passes over the column heads. That's right. Parking area. Deck meets columns at face mount. Different concrete strengths, 4,000 psi versus 6,000 psi. Critical cold joints conditions at face mount locations. 2. Evidence collection issues. Rapid demolition prevented detailed examination of the deflection zone. NIST, Army Corps of Engineers, focused primarily on punching shear. Lost opportunity to verify the butterfly failure pattern. Pre-demolition photographs showing that the butterfly pattern weren't followed up with physical examination. 3. Construction method implications. Your description of the two different column slab interfaces is crucial. Pool deck, monolithic pour over column heads, better punching shear resistance. Parking area, face mounted with cold joints, potential weaknesses. The rebar continuously through columns versus termination at face mount. They did hit that correctly. This Claudia is not missing a beat so far. Different failure mechanism possibly at each interface type. This difference in construction methods between the pool deck and the parking area section could have created different failure modes. The face-mounted sections with cold joints would be more susceptible to separation under dynamic loading. Yep. They don't have the advantage of the because it's a cold joint, guys. Would you say the rapid demolition decision might have been influenced by immediate safety concerns that overshadowed the forensic investigation needs? Also, could ground-penetrating radar or other non-destructive testing have helped document the internal conditions before demolition. Yeah. So yes, ground penetrating radar, of course, would have been another data point. So yeah, it's yes, it obviously could have it would have added more data. Mapping the steel would have added a ton of data. That would be great. Also using a GPS global positioning um, system that you use for auto accidents, where you survey the site. What it should have been used. They did not. I did not see that equipment out there. They could have got data points on the butterfly, for example. They could have profiled that entire deck with thousands of data points in a matter of an hour or so, with thousands of data points using the same uh, system that used for auto accidents to determine, and that's the the survey equipment I just mentioned, and it's very accurate. It's it's a very nice system, and that would could have gotten a ton of data points, including the rebar that was sticking out of part of the column heads. All of that could have been data mapped. All of it, the car's location, the tire locations, different debris. All of it could have been mapped in safety, because that structure did not have to immediately come down at that over there where they were. In fact, they were just standing out there using that as a staging area for the longest time. So it can't be a safety issue at that point if you're using it as your staging area. Ultimately, they did take down the entire structure, but they went out of it like a bull in a china factory. They stated that they asked the contractor to help them see something if they saw something evidential. Of course, the contractor is a demo contractor. What would he know? It's evidential. It's out of his wheelhouse, or out of each operator's wheelhouse. They're, no offense, but they're just excavator operators. They're not investigators, structural engineering investigators. So I would say that they did not. They did not have experience with this, and they lacked, all of their minds lacked um, the ability to say we need to bring out the survey equipment to survey all this. The other problem I did since learn that they would only keep these Army Corps of Engineers. They were more worried about their family life, so they would only keep them there 1 week at a time. This took weeks to finally ultimately remove everything, but they would keep them there 1 week at a time, worried about that they should go home. So they didn't have any continuity of someone on the scene that could be able to follow through with this fully. Um, Also, there was no one that had that mind of being fascinated and driven to say, I'm going to get to the bottom of this. I think they just cared about that it was their job to just perform, and they just had to perform. Let's see what Claudia says. Your critique of the investigation process highlights several critical missed opportunities. Let me break this down. Missed documentation opportunities, advanced survey technology, high precision GPS mapping could have documented the butterfly failure pattern. Thousands of data points could have been collected quickly. Would have preserved critical dimensional data of debris, rebar positions, ground penetrating rebar could have mapped internal reinforcement patterns, would have provided valuable data about steel placement and potential issues, non-destructive methods that would have been done safely, investigation management issues, personal rotation problems, 1 week rotational disrupted investigative continuity, no single investigator followed the case through, lost opportunities for developing deeper understanding of failure patterns, expertise mismatch, relying on demolition contractors to identify evidence, excavator operators lacking forensic structural knowledge, no dedicated structural forensic experts maintaining oversight. But yeah, This would be more the investigative part is what I'm driving at on this one. So, timeline priority issues. Using the area as a staging ground contradicts urgent safety concerns. Rush demolition despite apparent stability of remaining structure. That was the part there I'm talking about, the deck, where they could have grabbed that data point. You couldn't say, well, we needed that. Remember, they broke the hole in the wall. They ran the hoses through it. They did a lot. They went back in the building to make sure people were not in there. So, no. Prioritizing demolition over thorough documentation. Now, I know the building was reported to be swaying. The other part of the building reported to be swaying. Also, that the debris was dangerous. It was definitely dangerous, right, to be working in there trying to clear it. But you know damn well, once they dropped that building, they weren't going to, try to pick somebody out of there at that point, alive. I mean, this seems to indicate a fundamental disconnect between the investigation's needs and its execution. The technology and methods existed to document everything thoroughly, but weren't in English, but weren't utilized. The bull in a China factory approach you described essentially destroyed potential evidence that could have validated or disrupted various failure theories. With a different investigative approach, perhaps one modeled after aircraft crash investigation, where every piece is documented and preserved. I'm going to say an archaeological approach. Yes, I think more of an archaeological approach to do this, including the everything from identifying the materials, photographic videos, constant video of the entire site, um, to be able to document the evidence, sign-in sheet, locations of where you were signed in, at least being able to identify them with uniform. So if you're walking through the field, what I noticed about NIST, NTSB, etc., the jackets are not labeled, besides with NTSB on it. They're not labeled with identifiers such as NTSB 101 on the back of the shirt. Each person having a, let's call it an identifier on the back of their jacket, a permanent identifier. So you're let's say um, um, NTSB agent 101, like a badge that they have to wear it on their cap, like identifying their police car, that they would have to wear it. So wherever they're walking at any given time, when you want to videotape, when you're videotaping, you can say, look, you were here in this zone, because they didn't zone it out either. Eventually they did with this, they allowed another foreign country to come in and do an investigation. They zoned it out to find, to recover bodies, and what they thought the building structure would be. Um, so now we have the jackets would be a great identifier. So wherever they're walking, you'd be able to say, "Look, you were in the film at this point. You went into that zone. Why'd you go there? What are you doing?" And you can see you can track what each NTSB worker is doing at that point, and you can figure out, or everybody there, and you can give each person that might want to be a rescuer helper a jacket, and it could be a large tag that you tag on each person's shirt with pins, so they can come in their own clothing, and you would have big tagged um, a label that can be read easily, front and back. So it'll be the front of the plate on their chest and on their back, and if they got a cap, depending on the style of it, you would give them alternate another pin for their cap, so you can identify them from top, front, and back. And now you'd be able to, any one time, you'd be able to identify each other also. If you need to call out to somebody, say for safety reasons, you see person 101 doesn't know they're in trouble, but they will know that their name, their badge is 101 now, no longer their name. You identify them as that. You can scream, 101, look out. And that would make them 101. Anybody could identify 101 to tell them to look out, him or her. So that's my statement there. The other one is, I'm not sure if a structural engineer would have been right person for this. More archaeologists would be a good person to archaeologists. Yeah, I'm going to stick with that. And or if you can teach, if you can quickly teach, like the state police uses that GPS system I told you about. If you can quickly teach them how to mark everything off, that look, I need all the elevations. So do all the elevations. Give me all the steel you see. Just hit everything. And remember, this person be filmed also, so you'd be able to go back in time, as the person could do it real quickly. All right, that's my take on that. What do you think? Let's see what he says, and I'm going to end the video, I think, guys. Your proposed archaeological forensic approach is fascinating and addresses several key investigative deficiencies. Let me analyze the key components. Personal identification systems, clear visual identifications, standard identifiers, that is NTSB 101, multiple position visibility, front, back, cap, easily readable at distance, enables quick safety app communications, zone management, site gridding like archaeological digs, personal tracking by zone, documentations of who was where and when, documentation protocol, continuous video coverage, GPS mapping of all elements, high resolution photography, sign in, sign out procedures by zone. The archaeological approach makes sense because, remember, the sign in, sign out is for the safety of the people too. You know, okay, they're not stuck up in there. They didn't fall somewhere in the field there. They cleared. They signed their name out. All right, methodology. The archaeological approach makes sense because methodical documentation of spatial relationships, preservation of context, detailed mapping and photography before moving anything, experience with layered failure analysis. Your point about using state police GPS expertise is particularly clever. Existing expertise and detailed scene documentation. That's why the state police. And he says, clever. Thank you, Claudia. Equipment already available. Yes. Trained personnel and systemic documentation. Rapid data collection capability. All right. The interdisciplinary approach you're suggesting, combining archaeological methods, police forensics, and structural engineering, could have provided better evidence preservation, more systemic documentation, clearer chain of custody, better spatial understanding of the failure sequence, with adding a drone, oh my gosh, it knows about photogrammetry, yes. To create detailed 3D models also have been valuable in this context. This could have provided another layer of documentation before any material was moved. Yeah, I think they did use the photogrammetry. I think they did use that. It's like that beautiful 3D stuff. It's beautiful. So I won't just reply to it. All right, take care, guys. This is a 48-minute video. And Champlain Towers South. Let me ask you, does it know about the Champlain Towers South? Are you familiar with the Champlain Towers South structure? And this is what I was basically detailing. And if you're familiar with the Champlain Towers South in Florida, what do you think of this approach and what I stated? And yes, they did use the 3D photographs. They did use that, a drone, with a drone, I believe. But what do you think of that? Of my version versus what you can find in the data sources of Champlain Tower South. Yes, I'm very familiar with the Champlain Tower South collapse, Surfside, Florida. Your analysis provides several insights that differ from or expand upon the commonly discussed failure mechanisms, particularly your butterfly failure theory of the pull deck. Focus on flexual failure rather than just punching shear. Emphasize the importance of the 21-foot span. Highlights the early repair history within the first year. Questions the effectiveness of the urethane repairs as potential making things worse. Your construction sequence concerns. Initial set issues due to sandy substrate. Potential inadequate temperature, temporary supports. Different column slab interface conditions between pool deck and parking areas. Questions about concrete strength transitions at columns. 3. Investigative critique. The rapid demolition potentially destroyed evidence. Lack of proper forensic documentation. No systemic archaeological style approach. Rotating investigation teams limiting continuity. Your analysis differs from many published accounts that focus primarily on the punching shear failure mode. You've made a compelling case that the flexual failure of the deck preceded the punching shear failure, with the urethane repairs possibly masking but not addressing the underlying structural issues. Would you say that the NIST preliminary report focused on the punching shear mechanism might have missed some of these early warning signs and construction-related issues you've identified? All right, I'm gonna buy this, but it's early in the morning here, guys, so I'm gonna time myself out. It's 50 minutes in this for you, but yes, very familiar with it. It says your analysis is different from the many published accounts that focus primarily on the punching shear failure. You've made a compelling case that the flexual failure of the deck preceded the punching shear failure. So I give it an A for oh shit. Bye.